All right, now we're gonna look at PortFast and BPDU Guard, protecting access port. So here's a real world problem that happens every single day in enterprise networks. So a staff member, say in our network, Johannesburg office, unplugs their finance PC, maybe to charge it, then plugs it again, or replugs it back in again. So the switch port goes through STP conversions, blocking, listening, learning, all right, forwarding. So taking up 30 seconds. For 30 seconds, the PC cannot reach the network, and then the user calls the help desk saying, "My network is broken." So this happens dozens of times a day across a large office. Now the fix is PortFast. So on access port that are connected to the end devices like PCs, laptops, printers, IP phones, etc. A switching loop is impossible because a PC does not send BPDUs. Now a PC does not create a loops. So the 30-second STP convergence delay is just completely unnecessary. Now PortFast skips it. So the port goes immediately to to forwarding state, right? Now here's an important thing: never enable PortFast on trunk port, all right, or a port connecting to another switch. So if the port with PortFast receives a BPDU, which only happens when another switch is connected, it means that there's a potential loop and STP must run normally. Now PortFast on a trunk port is a network disaster waiting to happen. Now let me show you how to configure that. So what switch is this? Let's go to switch 1, where we're connecting finance. So finance is connected to switch 1. I think it's port 1 and 2, if I'm not mistaken. So here we'll enable and then configure terminal, and then we will look at interface. We'll configure interface fast Ethernet 0/1. Okay. Okay, so I got my spelling wrong here. All right, then we'll do spanning tree PortFast. All right, so we do the same thing with port 2. And then we do the same thing with port 3. And then with port 4 as well. And then end. So, or you can just use global command to enable PortFast on all access port at once. So this is the enterprise approach, faster and cleaner. So with the global, you can just say let's configure terminal, then you can just say spanning tree PortFast default. So this enables PortFast on all access mode ports automatically. So now the global command only applies to ports configured as switch port mode access. Now the trunk ports are automatically excluded. So this is the safest way to deploy your PortFast across the entire switch. Now the PortFast just solves the convenience delay, but now we have a new risk. A PortFast port just keeps the STP conventions, which means that if someone plugs in a switch into another PortFast port, that switch could create a loop and the port will never run STP to detect it. All right. Now BPDU Guard is the protection against this. So the BPDU Guard says if any BPDU arrives on this port, any spanning tree message at all, immediately shut the port down, and then error-disable it. So because the only device that sends BPDUs is the switch, and the switch should never be plugged into an access port. Now to configure it, we can just say configure terminal, and then we can just say spanning tree PortFast BPDU Guard. Okay, I think I've got guard there. How do you type guard? Yeah, default. Now if anyone plugs a rogue switch into a finance PC port in our office, the port immediately goes into the error disable state. All right, so it shuts itself down, so no loop can form, then the network is protected. All right, now let's do a simulation of a link failure and STP conventions. Now let's simulate the whole point of having redundant links and then automatic failover when a primary link goes down. So watch what happens when we shut down the active link from switch 3 to switch 1. All right, so first let's show okay, on switch 3, let me just close this. On switch 3, let's show spanning tree VLAN ten. All right, now note down which of the switch 3 port is a root port, forwarding towards a switch 1, and which is an alternative blocked. Now let's go to let's ping to a management PC 1. Desktop, and then go to command prompt. Let's ping 10.10.1.10. So we are pinging the finance PC 1, right, which is 10.1.10 on the switch 1. So we need to confirm, and it's working. You can see that it's working. So there is 4 replies. Now let's simulate a link failure. So I'm gonna shut down the active uplink on switch 3. All right, so let's go to it. I'm gonna go back to switch 3. Hopefully you didn't close it. Let's make this a full screen, and let's configure terminal. Oh, must enable first, ne? And then I configure terminal, and then interface interface terminal. What am I typing? Is interface gigabit Ethernet, gigabit bit Ethernet 0/1. My spelling, Ethernet. I'm missing an H here, Ethernet. Alright, and then we're gonna say no shutdown. And then end. So after we restore the link, so the network, you will see the network will recover automatically. So there's no manual intervention, no help desk call. So STP will detect this failure. It will run a mini election and then and unblock the alternate path, all within 30 seconds. So after it has restored the link, then the STP coverage will be back to the original topology with G02 blocked again. Now we can just run show spanning tree VLAN 10. So everything is actually restored within a few seconds as well. Now let me there's another something called rapid spanning tree. Let me quickly show you how to upgrade from a classic spanning tree to a rapid spanning tree on our network. So because in a real-time enterprise you'll always run a rapid spanning tree or PVST plus. So the 30-second convergence times of a classic STP is unacceptable for a modern network. Let's go to switch 1 and then just summary do that, because we must do the same thing in all the 3 switches. So we're just gonna be enable and then configure terminal and spanning tree mode rapid PVST. All right, and then end. Then you can verify by showing show spanning tree summary. All right, now let's do the same thing on switch 2, and then we'll end with switch 1. So we can just spanning tree mode, which is a rapid PVST. And end. All right, hopefully So we can also show summary, show spanning a tree summary. So you will see that the first line actually will say you will say switch is in repeat PVST, right, mode. So this output now shows that a repeat PVST mode. So with this active, when you simulate the same link fail again, the block port will go to forwarding in under 2 seconds instead of 30 seconds. Right. So in a production environment, users will barely notice the failover. So in some cases, they will even not notice at all. All right. So let's do the same thing on switch. Switch 1 or switch, which one? 3, switch 3. So here is configure terminal and then spanning tree mode, repeat PVST. And then we can confirm. Right, then we can see that it's all good. That was actually a very long lesson that we spent over 3 days. So we started with a devastating the problem of a devastating problem of broadcast storm. So what happens when redundant switch links exist without spanning tree? So we saw in the simulation mode frames multiplying exponentially and then the network paralyzed in seconds. Then we went deep on how STP work, the root bridge election using bridge ID and priority, and then port roles, root port, designated port, and then blocked alternative port states, blocking, listening, learning, forwarding, and why PortFast exists, just to skip the 30-second delay to a PC port. And then in packet tracer, we added switch 3 to our network, creating a triangle topology, and then we verified STP was running, demonstrated the broadcast storm by disabling STP, then re-enabled it. So we manually set switch 1 as a root bridge for VLAN 10, 20, and 30, and then continuing our 10.10.something.0/network address scheme. So we configured PortFast and then BPDU Guard on all PC facing port, and then we simulated a link failure and watched the automatic failover, and then we've upgraded the whole network to repeat PVST plus. So now our LAN has VLAN segmentation, it has inter-VLAN routing, and resilient redundant switch infrastructure protected by STP. So this is an enterprise-grade network design. So the next thing that we're gonna do, the next lesson will be the ether channel. So we're going to bundle multiple physical switch links into one logical high bandwidth pipe. So think of it as converting a single lane road into a highway. So multiple gigabits of bandwidth, automatic load balancing, link failure tolerance within the bundle. So I'll see you on the next lesson.